This video is hypothesis testing, null and alternate hypothesis, part 2. So we were talking about how to write the null and the alternate hypothesis statements. So for the null hypothesis statement, you'll either write, you'll start by writing the notation for null, H subscript O, and then you will write your parameter notation, the parameter symbol, mu or capital P for, the mu is for population mean, capital P is population proportion, and set it equal to whatever number. And then for the alternate statement, you are going to make a contradicting statement. So you will either say that the mean is less than or greater than or not equal to whatever that number is, or if it's proportion, you do the same thing with less than, greater than, or not equal to, not all three, just one of those, and you label it with H subscript 1. So let's look at example 2. Last year, the menu amount spent by customers at a restaurant was $35. The restaurant owner believes that the mean may be higher this year. Write the null and the alternate hypothesis statements. So the null statement, we will start by writing H subscript 0, and we are reading a claim about a mean. So we are going to use mu as our symbol for the parameter because we're doing mean. Now remember, the null is always equals. This is the assumption before, think about a trial. In a trial, we're innocent until proven guilty. So what are we assuming is true until we can prove otherwise? We are assuming that the mean is 35, so that it equals 35. Now the alternate statement is the prosecution. It's going to contradict that the mean equals 35. So if the mean is not 35, what should we write? Well, what does the restaurant owner believe? He believes that it may be higher. So for higher, you're going to use greater than 35. Now notice a couple things. One, the numbers in both statements are the same. Okay, that's always going to be true. Another thing to notice, which we've discussed before, the null has an equal sign. It always has an equal sign. The alternate statement always has an equality sign. Inequality sign rather. So either a less than sign, a greater than sign, or not equal to. We will use greater than when we say things like higher or more than or increased. We use less than for words like less than, it decreased. And then we also have this symbol. This symbol is not equal to, and we use that if we know that it's different, but we don't know how it's different. We don't know if it increased or if it decreased. We just know that we don't think it's 35. Okay, so that's all we had to do for this one. Is just write a null and an alternate hypothesis statement. So here's example 3. Newborn weight. In a recent year, the mean weight of newborn boys in a certain country was 6.6 pounds. A doctor wants to know whether the mean weight of newborn girls differs from this. So pause the video and try to write your two statements, one null, one alternate statement, and then unpause to see how you did. Okay, so here's the null. We are again talking about a mean, so we're going to use mu. The null is always an equality statement. So what do we assume is true? We assume that the mean weight is 6.6. That's what we're assuming is true. So for the alternate, it has to contradict it. It can't be equal. Now, do they imply that it's less than or greater than? They imply that it's just different. They use the word differs here, but that means different. So for our alternate statement, let me change the color here. We're going to say that it doesn't equal 6.6. So the mean equals 6.6 is the null, our assumption, and the alternate statement, what the defense is trying, or the prosecution is trying to prove, is that it differs from 6.6. All right. Example 4, gas mileage. A certain model car can be ordered with either a large or small engine. The mean number of miles per gallon for cars with small engines is 25.5. An automotive engineer thinks that the mean for cars with the large engine will be less than this. So again, write a null statement and an alternate statement. Pause the video, and when you're done, unpause it to see if you got the right answer. Okay, so for the null, again, we're talking about a mean. We're assuming the mean equals 25.5. We're assuming that it equals that of a small engine. And the prosecution, the alternate statement, we're believing that it is less than that, than the 25.5. All right. This one says a pollster thinks that less than 30% of registered voters in the county voted. I'm going to do this one with you. So notice we're not talking about a mean. We're talking about a percentage or a proportion. So we're going to say P equals. All right. So the pollster thinks that it is less than what? 30%. So you could write 30% like this, which means that the assumption is that it equals 30%. Now this one you can write two ways. Let me just show you in a different color. You can also write P equals 0.30 and H1 P is less than 0.30. Now later I'll talk about how to put these in the calculator to actually perform the test. This is how it needs to be put in the calculator. Don't put it in as a percentage, put it in as a decimal. All right, you guys try this one. Example 6, mean GPA. We want to test whether the mean GPA of American college students differs from 2.0. Pause the video. When you come back, we'll have the answer. For the null, we're talking about mean, and we're assuming it equals 2.0 because the alternate statement, the prosecution believes that it differs. Differs, use the not equal to symbol. Differs from 2.0. All right, example 7. In an issue of U.S. News and World Report, an article on school standards stated that about half of all students in France, Germany, and Israel take advanced placement exams and a third pass. The same article stated that 6.6% of U.S. students take advanced placement exams and 4.4 pass. Test if the percentage of U.S. students who take advanced placement exams differs from 6.6. Really, this is what you need to focus on. That's my hint to you. So pause the video, see if you can come up with two statements, and then unpause to see if you're right. Okay, for the null, we are testing percentages or proportions. So we're assuming that the percentage is 6.6%, or we can say 0.066. That's 6.6%. And the alternate statement is that it differs, so not equal to 6.6%. Again, if we write it as a decimal, you would say not equal to 0.066. Okay, so on to something called type 1 and type 2 errors. So since the null and the alternate hypothesis are contradictory, one and only one of them must be true. Let's just go back and look at this. You can't have a proportion equal to 6.6% and not equal to 6.6% at the same time. It's not possible. Okay, so that means one has to be true and the other one is not true. So if the null is true, this one's true here, and we fail to reject it, we've done the right thing. We only reject the null if we believe that the null is false. Okay, so if the null is true, we don't want to reject it. We want to fail to reject it. That's the correct thing to do. Similarly, if the null is false, we do want to reject it. Okay, so if this is false, the null is false, we want to reject it. Okay, because it's not true. But if, on the other hand, the null is true and we reject it, we did the wrong thing. We made a mistake, and that kind of mistake is called a type 1 error. So when we reject the null and it's a mistake, that is a type 1 error. If we reject it when we shouldn't, it's a type 1 error. If the null is false and we fail to reject it when we should have, that's a type 2 error. So you only make type 1 errors if you reject the null, and you shouldn't have, and you only make type 2 errors if you fail to reject the null, and you shouldn't have. Okay? So type 1 error is when you reject it, but it was a mistake. Okay? Type 2 error is when you fail to reject the null, and it was a mistake. Type 1 error when you reject mistakenly. Type 2 error when you fail to reject mistakenly. So let's look at some analogies. In a medical test analogy, the null is that you do not have the disease. That's the defense. A type 1 error is if we rejected this. We rejected you don't have the disease. We said that's false. So that means we're saying you do have the disease, but because it was a mistake, that would be considered a false positive. A type 2 error is when we fail to reject the null, but the null, but we should have really rejected it. Okay, so we're supposed to reject this, that you don't have the disease, implying that you do, but we failed to reject it by mistake. So we're saying that you don't have a disease, or we're saying that we can't prove that you don't have the disease. So in that case, you would get a false negative, which is more serious because you really do have the disease, and we're saying you don't. I like this next analogy because it puts it with the trial analogy like I've been using all along here. The null is that you're innocent. So a type 1 error would be rejecting the null, rejecting innocence, which means you would find the defendant guilty. And that's pretty serious. It's sending an innocent person to jail. Whereas a type 2 error is if you fail to reject the null. You don't reject that they're innocent. So you're saying they're not guilty, is basically what you're saying, when they really are guilty. So you're letting a guilty person go free. I think both of those could be considered serious, especially if it's a capital crime like murder. But anyway, so there's those analogies. Type 1 error is when you reject the null but shouldn't. Type 2 error is when you fail to reject the null but should not. Okay, we're running out of time on this video, so we are going to stop here and pick up with example 1 for error types in part 3.